Hello everyone, we are Team Alpha. My name is Foram Mehta and my team members are Dhanashree Gaonkar and Noopur Joshi.
Today I'm going to talk about understanding of CAP theorem. The CAP theorem is a tool that is used by system designers to trade off while designing network shared data systems. C in CAP stands for consistency, that is, all nodes should see the same data at the same time. A stands for availability, that is, every request should get a response on success or failure. P stands for partition tolerant, that the system should continue to work despite of a message loss or partial failure. The theorem states that network shared data systems can only guarantee support of two of the following three properties at a time. First is CP, that is consistency and partition tolerance. It refers to category of systems where availability is sacrificed in case of network partition. AP, that is available and partition tolerant. These are the systems that are available and partition tolerant, but it cannot guarantee consistency. CA are consistent and available systems, but in case of absence of any network partition. So often, a single node DB server categorized as a CA system. Now, these DB servers, they do not deal with partition tolerance and hence they do not fall under the preview of CAP. So, the correct way to think about CAP is that in case of network partition, one needs to choose between availability and partition tolerance. In any network shared data system, partition tolerance is a must. Network partitions and drop messages are a fact of every application and hence must be handled appropriately. The goal of every system must be to maximize combination of consistency and availability that makes sense for a specific application. So consequently, the system designers must choose between consistency and availability depending on the application needs.
In this video, I'm going to demonstrate the behavior of MongoDB in case of partition tolerance. So the first step that we need to do is to create 5 EC2 AWS EC2 instances in which we'll install MongoDB and demonstrate the behavior of MongoDB in case of partition tolerance. So we have created the 5 EC2 instances. As you can see on the screen, all are up and running. These have been made based on the basic configurations which you can find on the AWS website for creation of EC2 instances. All of them have been created in the same VPC, which we have named as the Comp281 VPC. You can see the configurations on the screen. Next, all the EC2 have been assigned the same security group. The security group will allow any request coming to it on port 27017, as that is the default port used for MongoDB, and all the traffic is accepted in the outbound rules. Next, when we'll install MongoDB on our EC2 instance. So there are 4 steps for installing MongoDB. First, we'll create a repo file, and then by using the commands mentioned on the screen, we'll initiate the setup of MongoDB. We will copy the content into the configuration file as given in the step below. The content is given on the screen. This content will also be included in the GitHub repo, whose link would be mentioned in the YouTube video. The next step would be to actually install the MongoDB using yum command. And the last step would be to make a default DB directory for MongoDB. The MongoDB daemon cannot be run without creating this instance, and we will make the EC2 user, that is the instance, the owner of this particular directory, so that it can have any read or write any permissions it needs. So now that this is done, we'll have all the instances with Mongo installed. Next, we will create a MongoDB authentication file, which will be shared amongst which will be shared amongst all the EC2 instances while communicating. So it will make it more secure. The 4 commands mentioned on the screen will help in creation of that file. Next, we will make changes to the MongoDB configuration file. The first change is to comment out the bind IP line mentioned in the file. By commenting this line, we are our EC2 instance, our Mongo daemon will listen to listen to all the IP addresses coming. Listen to requests from all the IP addresses coming to it. Next, we will change the authorization and enable the we'll enable the authorization feature over here, and the authorization will be done based on a key file. The key file was created in the previous step, the Mongo internal key file. This file has been created on one of the nodes and will be copied to all the other remaining 4 EC2 instances. Next, we will edit the replication. Next, we will edit the replication line in the config file. So we'll basically add the replica set name of our cluster. In this case, we are taking it as RS0, sorry. So this summarizes all the MongoDB config changes that we need to do in order to run our replica set. So next we'll move on to the replica set configuration. So the first step in this would be to start all our MongoDB processes on all the EC2 instances. Point number 1 will specify the command using which we'll start all the instances. So we, by saying --bind IP all, we are allowing all the requests coming from, that is all the traffic coming to the MongoDB servers to be accepted. And we are starting this with by specifying our replica set name over here. Next, what we'll do is we'll on one of the nodes we'll do our on one of the instances of having MongoDB running MongoDB, we'll run the command rs.initiate. This command will help in initiating our replica set. Next, from the primary, by doing rs.initiate, we're making it as the primary node. From the primary node, we'll fire the below command. So the third command, which is doing rs.add, that command will add all the 3 secondary nodes. So in this instance, we have 1 primary node, 3 secondary nodes, and 1 arbiter node, which would be helpful in case of leader election. So when we are trying to add secondary nodes, we'll fire the command as rs.add, having the IP address and the port number. And in case of adding the arbiter node, we will fire the command as rs.addArbiter, passing the same parameters. So this will create a basic setup for our replica set by joining all the nodes together. And the last step in this replica set configuration would be to enable replication across all nodes. So in this case, what we want to do is we want to read and write requests from the primary node, only the primary node, and in case of failure of the primary node, we want to switch to the secondary node. So when we write on our primary node, we want the entry which was written in the primary node to be reflected across all the other secondary nodes. So rs.slaveOK command will be run on all the secondary nodes, which would enable replication on all of those nodes. So whenever we try to write in our MongoDB, as in add a document in our collection on the primary node, this document would be copied across or replicated across all the other secondary nodes. So in order to test this in order to set all of this configuration, we have created a Go API, which will run through Postman and try to test our API. So next we will start testing our API.
Now to test partition tolerance in my MongoDB, I have created an API in Go for the basic CRUD operations and testing of my MongoDB replica set. So firstly, I'll create a Dockerized container of my Go application. Once that is done, I'll run my container and I'll expose the port of my container on 3000 so that I can request through the Postman. So my application is up and running through Docker. I can go to Postman and first try and test if my Go application is running or not. So it is up and running. So the first partition tolerance testing, the basic testing that we can do is to check whether the replica set is actually functioning well or not. So the first step is replication testing. So the expected output here is that once I insert a document in my primary node, I should be able to read it on any other secondary node. So there is an important step to do when we initiate a replica set is after the initiation of a replica set, I have to run the command rs.slave on all of my remaining secondary nodes. Okay, so to start replication, run command on slave as rs.slave. So every time MongoDB is stopped, this command should be executed on the secondaries, otherwise replication won't take place. So this is something that we should keep in mind. So we can just go to one of the MongoDB instances and run the command rs.status. This will show you what is the health of all my instances in the cluster. So as we see, health 1 means that the system is healthy, up and running. This is my primary. Okay, so let's just insert a document through this. So I'll make a, let's say, post call through my Go API to my MongoDB. So I'll just give you a quick walkthrough of what I've done here. So for replica testing, we'll try and insert a document in my primary node and check and see whether I am able to see the same document in my secondary nodes as well. So I'll hit a post request. Please note the ID here with 65 so that we can query that later. Okay, so this has been inserted in my primary. We'll go and check our second. One is fine. So I'll just switch to my admin DB and fire the command to find my document with ID 65. Yeah, so here you can see clearly it has been replicated. So thus we can see that our first test case has been passed and we can say the documents being replicated to my secondaries. We can just, to be sure, test another secondary as well. Yeah, good. Okay, so now let's move on to our second test. Now we'll move on to our next test case where we'll test the partition tolerance and see that our even though our secondary is not able to communicate with our primary because of the partition or network failure, but still we are able to read the updated data in our secondaries. So this shows us that MongoDB supports high availability. So let's test it. So for that we'll just use this command where we'll create a firewall between our primary and our secondary. So we'll go to one of our secondaries and fire this command to add the firewall. And okay, the good way to do this would be to go to rs.status to see what is the IP of our primary. Okay, as you can see, the IP of our primary is 10.0.99. Okay. Yeah. This is giving some error. Let me check. Okay. Yeah. So that was the mistake that we were doing, I suppose. We have to go out of our MongoDB shell and hit this command. So that we can execute it successfully. And don't forget to add sudo to your command because that should be done in the root mode. Yes, that's done. So this will stop our communication between the primary and the secondary. So we can just check rs. rs.status. Oh. See, so you can see the unable to reach primary for set rs0 here. Okay, so now if I insert, so now let's again insert a document in our primary. Save it. Let's change this. So this has been inserted in our primary. Now let's again query our secondary. close admin. So db.admin.file. ID 70. Yeah, so as I pointed out earlier, every time you stop the MongoDB terminal, you have to execute the command rs.slave. Okay, so let's do that first. So did you try and hit the command again? Now let's query our secondary to see whether we are getting the updated data or not, even if we have created a firewall between a primary and a secondary. So let's do this. And so we had tried to insert so as we can see, even though we had created a firewall between a primary and secondary, we are still able to read the updated data. Okay, so this will help us to move on to our next test case, wherein we'll create a firewall between not only our primary and secondary but to all the rest of the secondary, so that the secondary that we are that is our candidate right now is isolated from the entire network, and thus we'll only read the dirty data or the stale data. Okay, so to do that, we will again exit from our Mongo bash and okay, suppose we've been locked out, so we'll SSH again to our system. So this is how you connect securely to your EC2 instance. Okay. So Mongo is still running. Yeah. So what we'll do is, as you can see here, we'll have to create firewall between our current secondary and the rest of the secondary. So it would be better to check the IPs of the rest of the secondaries using rs.status. Okay. So our primary is still not connected to the current secondary. So the other secondary that we need to disconnect is 258 and 2201. Okay. Let's do it. Created 2201 for the command to 58 and 201. That's done. Let's again go inside our Mongo shell. Okay, now to test this, we'll again we'll try to insert a document in our primary. Let's say this time 71. Let's try and insert this. Okay, it has been inserted. Now let's try and check this in the secondary that we have isolated from the network. Okay. Yeah, so we are not getting any output here since our current secondary is isolated from the entire network. It is not even being eventually consistent. Yeah, so now we can move on to our last test case, that is leader election. For the leader election testing, let's first check the IP of our primary node. So currently the primary node in our case is 10.0.299. So let's step down the primary node for 11 seconds. Yeah, so now as you can see here, our primary has become the secondary, and now if you check the status, so earlier the primary was 10.0.299. now the primary is 10.0.2.201. so thus it has re-elected the new leader. So this test has also passed successfully. So thus we have tested on 4 different use cases. So one being replication testing, second being leader election testing, third being AP testing wherein updated data is still being read on the secondary, and fourth being AP test reading where stale data is being read from our isolated secondary node. So I would like to give you a walkthrough of my project journal, how I went through with my personal project in the 4 weeks entirely. So the objective of my week 1 was to research initially on the different kind of NoSQL DBs that I can use for this project, and what CAP theorem is, and like comparison between MongoDB and React or Redis. So these were my findings for CAP theorem and the requirements of the project that I have understood from the article that our professor had shared with us, and also what is exactly partition tolerance and what are its pitfalls, and also what are the benefits of using MongoDB for my project, like why did I select MongoDB to test partition tolerance. So that was week 1 for me. And then for week 2, my objective was to set up the MongoDB cluster with replica set configuration. So as displayed earlier, I did the setup and configuration as follows. And for week 3, my objective was to create the Go API for the CRUD operations and error handling for my MongoDB communication so that I could test the AP properties. So I had to research on how would I connect my MongoDB using the Go API. So I had to use MGO driver, that is the MongoDB driver for Go language. And then I started with first writing the basic connection functions to connect my MongoDB through my Go API, and then thus I went ahead with writing the CRUD operations. So for the objective of week 4 was testing the AP property. So I had created these 4 test cases which were exhaustive to understand how partition tolerance would actually work in MongoDB. I would link below the URL for my GitHub repository, so you can have a look at how I have documented, and you can also get the source code for my Go API there. Thank you so much.